integrate natural log e power x plus 1 divided by e power x minus 1. To solve this problem, we start to divide the numerator and numerator by e power x. The integration will be I equal if we divided the numerator by e power x, it will be 1 plus e power minus x. The denominator will be, if we divide the denominator by e power x, it will be 1 minus e power minus x dx. Inverse hyperbolic x equal half natural log 1 plus x divided by 1 minus x. i.e., this will be this integral inverse hyperbolic e power minus x equal half ln 1 plus e power minus x divided by 1 minus e power minus x. So we can reduce this integral to be I integration from 0 to infinity inverse hyperbolic to inverse hyperbolic e power minus x dx. So this integral will be reduced to be at this I equal integration from 0 to infinity inverse hyperbolic e minus x dx. To solve this, we use integration by parts. D I e power minus x 1. Differentiation this minus 1 minus e power minus x squared. Differentiation of e power minus x will be minus e minus x. So the integral will be I equal to x multiplied inverse hyperbolic e power minus x plus from 0 to infinity plus the integral from 0 to infinity x e power minus x divided by 1 plus e power minus 2x dx. This term will be 0. At x 0, it will be 0. At x equal infinity, this will be 0. So this term will be term eliminated, 0. So this integral will be reduced to b original integral will be reduced to I equal integration from 0 to infinity to x multiplied e power minus x divided by 1 minus e power minus 2x dx. This will be solved by integration by parts. First, we will reduce this formula to be I equal to integration from 0 to infinity x multiplied e power minus x multiplied 1 over e power minus 2x minus 2x dx. 1 divided by 1 minus e power minus 2x. This will be infinite series equal summation from 0 to k, from k to 0 to infinity, e minus 2kx. So I will be 2 integration from 0 to infinity x I equal integration from 0 to infinity x e power minus x sigma from k to 0 to infinity e power minus 2kx dx. I equal to sigma from k to 0 to infinity integration from 0 to infinity x e power minus 2k plus 1 x dx. We solve this integral by integration by parts. D R x e power minus 2k plus 1 x differentiation of x 1 differentiation of 1 equal 0 differentiation of integration of this will be e power minus 2k plus 1 x divided by minus 2k plus 1. Integration of this will be e power minus 2k plus 1 x over t 2k plus 1 square. So the integral will be will be reduced to b. This integral will be reduced to b I equal to x multiplied e power minus 2 k plus 1 x divided by minus 2k plus 1 minus e power minus 2k plus 1 x. This is from 0 to infinity divided by 2k plus 1 square from 0 to infinity. This term will be 0 at x 0, and at x equal infinity this will be 0, so this part will be 0. So the integral will be reduced to be I equal this minus e power minus 2k plus 1 x divided by 2k plus 1 square. This is equal at x equal infinity, this b will 0. At I equal to sigma k from 0 to infinity, this term will be 0. This term will be I equal to sigma from k to 0 to infinity. First term will be 0, second term will be minus 1 plus divided by 2k plus 1 square. So the integral will be reduced to be I equal to sigma from k to 0 to infinity 1 over 2k plus 1 whole square equal to at k equal 0 1, at k equal 1 equal, this is 1 over 3 square plus 1 over 5 square and so on. This will be equal to minus pi square over 8 multiplied 2. So this integral will be pi square by 4. This is the final.